My next discriminant question says, show that the quadratic equation, which is this one here, has two distinct real roots for all values of k. So again, we're going to be using the discriminant to find out whether that's the case. So I'm going to write out the equation. So it's question 2. Here we go. And it's going to be x squared plus 2k plus 3x plus k squared plus 3k plus 1 is 0. And they've been very helpful and actually organized this into coefficients. So really the way to think about this is we've got an x to the power of 2, an x to the power of 1, I'll write that in, and an x to the power of 0. And the coefficient of x to the power of 0 is all of this. So really you could actually rewrite this as x squared plus 2k plus 3 as a coefficient of x plus, and I'll put this in brackets here, k squared plus 3k plus 1 x to the 0, this is x to the 1, is equal to 0. So you've got a coefficient for x squared, which is a 1, a coefficient for x to the 1, which is 2k plus 3, and a coefficient for x to the 0, which is k squared plus 3k plus 1. That's the way to think about this. So that would mean that the a value is 1, and the b value is 2k plus 3, and the c value is all of this here. So here we go, 3k plus 1. So now we can write out using the discriminant, which is b squared minus 4ac, and we know it's going to has two distinct real roots, so it must be greater than 0. So the discriminant is this, which is greater than 0. Well, let's see if that's true. So let's go to 2k plus 3. So I'm going to have 2k plus 3. We'll populate the expression with the values we've got here. So that's going to be squared minus 4 times a, which is 1, times c, which is this thing here, which is k squared plus 3k plus 1. All right, and all of that's greater than 0. It becomes a bit difficult to keep the inequalities directly under each other, but we'll do our best. So this becomes 2k plus 3, 2k plus 3. And that's now expanded this little bit out here. Minus, and I'll just put a 4, k squared plus 3k plus 1 is greater than 0. I'm going to expand this all out now. So 2k times 2k, that's going to be 4k squared. 3 times 3 is 9 plus 9. And I've got 3 lots of 2k, which is 6k, and another 3 lots of 2k, which is 6k. So it's going to be plus 12k. That's a 12, not an R, right? Okay. Minus 4k squared, and 4 lots of that is going to be minus 12k, and negative 4 times 1 is going to be negative 4, greater than 0. All right, now I can collect like terms a little bit here. So I've got a 12k and a negative 12k, and that becomes 0. I've got a 9 and I've got a negative 4. Well, 9 and negative 4 is going to be a 5. I can just pop that down there. And I've got a 4k squared and a negative 4k squared, which is going to be 0. So I've got 5 is greater than 0. So what we want to say here is that the discriminant, so therefore, the discriminant equals 5, which is greater than 0. Therefore, there are two discrete, real roots. And that's how I conclude it. Again, make sure you have your concluding statement at the end. Otherwise, it's really not going to be marked as correct.